Hi, I'll go over how to do lab 8 of ECE 286, which is regarding active filters. So for this lab, we will be using the 741 as an op amp. And the reason why we're using a 741 is because this lab is regarding active filters, and active filters require an op amp. And that's why the term, the active is there. Okay, for experiment 1, we have two configurations. And in this, we're essentially just trying to see how, in the first part, these components relate directly or inversely to the load. So the voltage measured at the input compared to the voltage at the output. And we want to measure the cutoff frequency. So in this case, this manual talks about using a maximum voltage divided by the square root of 2 to give you the cutoff voltage. But the only problem with that is when we do our frequency sweep on the M2K, you cannot get voltage, you get decibels. So the cutoff voltage occurs at -3 dB. So in a voltage versus time graph or voltage versus frequency graph, the cutoff voltage will occur at the max voltage divided by the square root of 3 or max voltage times 0.707. But in a dB graph, where it's dB versus frequency, you will have the cutoff voltage occur at -3 dB, and that is the standard. So when we do this, we will just use that. And then for this portion right here, it requires you to measure the voltage at the 5 frequencies. So it depends on, you would need to ask your TA this. I don't know if they will take just the dB voltage marks or if they actually want, like at 100 Hertz, it's 3 volts, while at 1K, it's at 1 volt. I don't know if they want the voltage, the dB. Just double check with them. But I'll show you what I have as my circuit setup. So here we go. This is my circuit right here. So I'm using the second reference circuit. And so here's my capacitor. I replaced my 1K input resistance with a 3K resistor. And then my load is still that 1K. And I'm supplying positive and negative voltage to the rails. And then I have a short going from the positive to the left positive to the right positive, and my right negative to my right negative, left negative from my rail. So that way I don't have to worry about too many cables. So that's my setup. And then now what I'm going to do is just go on to Scopy, pull it up, give it a moment to set up. So when you do use this, make sure you are supplying your positive and negative voltage to your op amps. If not, you won't get any results and you'll be dumbfounded like I was for a good bit. Okay, so now I am supplying a 1 volt signal at 1 kilohertz. Oh, sorry, wrong portion. Go to network analyzer. Now let's click on the 3 parallel bars on the right, top right that is. So I'm going to send in 1 volt, and then make sure you have a reference voltage. So my channel 1 is going to be the reference. So it's going to measure the voltage drop across my whole circuit right here. So across the capacitor and that resistor on the input side. And then channel 2, I'll actually make it measure my output. So there we go. So it's on my output now. It might be hard to tell, but it's on pin 6 of the op amp, and I'm just going to click single and give it a moment to complete its cycle. Of course, you can get more data points by scrolling down on the 3 parallel bar button and then going down to samples per decade. Of course, if you do increase it, it's going to take a lot longer. So that's just a drawback. So I'll actually start measuring where 3 dB is, -3 dB. So let's see. So if you look right here where it says mag1, you'll see that value change. So as I keep decreasing it, you want to just get to about -3 dB. Wow, that was spot on. Okay, so around -3 dB, I'm getting a frequency of about 660 Hertz, and that would be the cutoff frequency if I use a 100 nanofarad capacitor in series with a 3 kilo ohm resistor. And then that's how you do essentially part 1. And then experiment 1, that is. Experiment 2 is essentially the same thing, but you're increasing the capacitance or increasing the resistance. So the first part, you're changing that 1K resistor to a 10K resistor, seeing how the new input resistor is 10K, you do the experiment, you determine what the frequency is, the cutoff frequency. And then once you're done with that, you will revert that input resistor to the 1K and then add another 100 nanofarad capacitor in parallel. So what that ends up doing is you'll have two parallel capacitors. So you'll have 200 nanofarads in total as your capacitance. And that's how you would do part 2. It's the same procedure as I explained for part 1. Part 3, same thing, but you have you're replacing your load resistor. So your load resistor is going from a 1K to a 10K, and you're trying to determine if there's any changes in your frequency. And then for experiment 3, you have a different setup. So now you have this feedback resistor. So what I'll do is I'll connect my feedback resistor, and I believe it requires you to use a 1K. Yep, it requires you to use a 1K. So I'll just grab my 1K, and then make sure you do connect it properly because it is semi-odd how it is set up. Okay, so I'm connecting mine right now. Give me a moment. There we go. Cool. Okay, so I've connected my circuit. So here it is. So here's that feedback resistor going from my output to the non-inverting terminal of my op amp. And then from the non-inverting terminal of the op amp, I have my load connected to ground. And then I'm going to measure the voltage drop from the output. So you might try to measure from the the inverting terminal of the op amp. Don't do that. Measure it from the output. So from pin 6, measure it. And when you do that, at any given frequency, you'll see how the voltage changes. So I'll just do an example. So my op amps are powered. I'll go to my signal generator, and then I'll do a 2 volts peak to peak with a 1K frequency. If I switch over to my oscilloscope and then measure the input compared to the output. So I'm going to measure the input from the inverting terminal and then go and click single. You will measure a change, but I did not connect something right. Give me a second. Okay, my IC started coming out of my breadboard, but if you look at it, my peak voltage is about 1.7, and when I look at my peak input voltage is about 1.7. When I look at my output, it's about 3.4, so it's almost a doubling, which makes sense because that's how we're getting that gain. So that's how you do experiment 3. You have to do another additional step where you have to add another 1K in parallel with the initial 1K load and then measure the cutoff frequency again. But that's how you would do this lab. Good luck.